All right. I hope that first part of 11.6 was easy, relatively at least. Um, I don't, maybe a little bit too repetitious. So I'm going to reevaluate the assignment for 11.6b and see, check the length on that before I post it. But there's nothing new for this. There's no new notes. So I'm just going to do problem number 19 from 11.6a. So if you haven't already done 11.6a, then don't watch this yet because I want you to try this problem on your own. There's a couple problems that have this equation in them. So I want you to see if you can figure this out or even this style of equation. There's quite a few actually. So don't watch this if you haven't done 11.6a. So I am actually going to start with a sketch of the graph before I start solving algebraically. The key to this problem, I probably need to grab some more colors of markers, is getting that this is 4 over x, which that's easy, but that's 4 times, I don't know why I'm writing an arrow there. Still working on turning on my brain. 4 times 1 over x. The 1 over x, we know some ordered pairs for. The 1 over x graph. So 4 times 1 over x, we multiply the y values to get those as our ordered pairs for the graph. And I'm just going to draw a sketch of this. I'm going to do it in pencil. Let me see, I've got a circle centered at the origin and then I've got the 1 over x graph. So I'm okay with kind of a an origin centric graph. Set of axes, maybe I should say. So then my ordered pairs are -1, -4, and 1, 4. Just in case you don't remember, for the 1 over x graph, we've got the asymptotes, and then the curves look something like that-ish. That's not going to be perfect. I just said I was going to do it in pencil, and I did it in pen, didn't I? Well, that's all right. Let me get a different color for the circle. Hopefully you recognize this is a circle with the center at the origin and the radius is rad 8. I'm being a bad student, not turning my phone off. But I'm at home, so you can't do anything about it. Rad 8 is just under 3, right? Slightly less than 3. So my center, my circle, and now this is not the best graph, but it's go ahead and make fun of me. I'm not going to hear you. It's something like that, okay? That was fun. All right, so then let's start solving it algebraically. Substitution makes sense on this one. Again, there's no way to eliminate anything. We've got squared terms in this one. We don't have squared terms in this one, and we've got the x and y connected, so elimination doesn't make sense. So I'm going to take my circle equation, and I'm going to sub in my 1 over x equation, and then I'm going to start solving. And then now this is an algebra 1 problem. So I don't like fractions almost as much as I don't like words. So I'm going to multiply everything by x squared to get rid of the fraction. And I'm allowed to do that as long as I do it to both sides. So then I end up with a quadratic in form equation. It's actually a 4th degree equation, but it is quadratic in form. And multiplies to positive 16, adds to -8 is -4 and -4. But then I need to, my first times first to equal x to the 4th. So it's going to be x squared. That way my outer and my inner are both x squared terms. And then my first times first is x to the 4th. So then x squared minus 4 equals 0, and we can get plus or minus 2 out of that. And then we're gonna find the y values for each of those x values by subbing back in. I mean, plug it in where it's easiest. If you want to plug it in here, you can, but don't be a martyr. I'm gonna go y equals 4 over x. And y equals 4 over x. So now, this is why I wanted to do this in pencil, because now I can see it's actually kind of like a point of tangency right there and somewhere around there-ish. So those curves are tangent to each other. They only touch at one point. So there's that. I'm going to post this in the 11.6b. Well, you're already reading me posting it, so I don't know why I'm saying that. Hope you guys are doing well. Have a good weekend. Please don't work too hard. Give me feedback when needed. Stay healthy.